Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. Statistical methods 2. In the previous session, we have been discussing some basics about the theory of attributes, notations of attributes being represented in Roman letters and Greek letters, so that we can do some statistical treatment for the qualitative attributes for measurement in quantitative purpose. And after discussing the basics of attributes, we started with the consistency of data discussion. In continuation of the consistency of data discussion, in this session we are going to study about the consistency of the data further, and also independence of attributes will be studied. We have seen a theorem for the consistency of data, which says a necessary and sufficient condition for the consistency of data is that the no ultimate class frequency should be negative. That is, all the ultimate class frequencies should be non-negative for the data to be consistent. Now, based on the condition, we have some criteria for consistency of class frequencies, which are obtained by using the same theorem discussed in the previous session. For a single attribute A, we have conditions of consistency as follows. For a single attribute A, condition for consistency is A is greater than or equal to 0, and second one is class frequency alpha is greater than or equal to 0, means A should be less than or equal to n. For the case of two attributes A and B, the conditions of consistency are AB is greater than or equal to 0, then A beta greater than or equal to 0 implies AB minus A beta stands for A minus A beta, AB, A beta stands for A minus AB. So, A minus AB is greater than or equal to 0, or you can say AB is less than or equal to A. Alpha B is greater than or equal to 0 means B minus AB is greater than or equal to 0, or you can have AB is less than or equal to B. Alpha beta is greater than or equal to 0 implies AB is greater than or equal to A plus B minus n. Next, in case of 3 attributes, these are the 4 conditions of consistency for the class frequency. That is, A beta gamma is greater than or equal to 0 implies ABC is greater than or equal to AB plus AC minus A, and alpha beta gamma is greater than or equal to 0 implies ABC is greater than or equal to AB plus BC minus B. And similarly, alpha beta C is greater than or equal to 0 is ABC is greater than or equal to AC plus BC minus C. Then alpha beta gamma is greater than or equal to 0 can also be written as ABC is less than or equal to AB plus BC plus AC minus A minus B minus C minus of minus n, that is plus n. Now, based on these conditions of consistency, we can arrive at the relations between the class frequencies of order 2 and class frequencies of order 1, and then class frequencies of order 3 and 2 and 1. Now, 1 and 8 give, what is 1? 1 is AB is greater than or equal to 0, and 8 is alpha beta gamma is greater than or equal to 0. Based on this, we have AB plus BC plus AC is greater than or equal to A plus B plus C minus N. Similarly, 2 says A beta is greater than or equal to 0, which implies AB is less than or equal to A, and 2 and you relate 7. 7 is alpha beta C is greater than or equal to 0. Therefore, ABC is greater than or equal to AC plus BC minus C. Okay, and you have AB is less than or equal to A, and similarly AC will be less than or equal to A. So, based on this you have the condition as AC plus BC minus AB is less than or equal to C. Similarly, relating 3 and 6 condition, we have AB plus BC minus AC is less than or equal to B. Fourth condition and fifth condition gives you AB plus AC minus BC is less than or equal to A. Now, after studying the condition for consistency of the data and then criterion for consistency of class frequencies, let us examine an example where you are asked to examine the consistency of the following data. So, examine the consistency of the following data of a population of 1000 members. Capital N is equal to 1000 and capital A representing an attribute A. There are 600 members possessing the attribute A, and there are 500 members possessing the attribute B, and there are only 50 members possessing both the attribute A and B. Let us see whether the data given is correct or not by checking the consistency of the following data. Okay, the symbols having their usual meaning. Now, let us verify whether the data is correct or not by checking the consistency of the data given. We will take the alpha beta. Alpha beta has the usual meaning capital N minus A minus B plus AB. It is actually N minus of A plus B minus AB. This is how it is written. Now, all the values are given in the question. N is 1000 minus the attribute A value class frequency is given as 600, 500, then AB is given as 50. This gives you the value minus 50, which is less than or equal to 0. So, a class frequency is becoming a negative value. A class frequency means the class frequency of order 2 alpha beta is becoming negative. Therefore, the given data is not consistent. The given data is inconsistent. Since you have alpha beta is less than 0, the data is inconsistent. That is the conclusion we can arrive at the data given. Now, you can see what is wrong with the data given in the question. Okay, N is given to be 1000 and the number of members possessing the attribute is 600 and the number of members possessing the attribute is 500 and the number of members possessing the attribute A and B is 50. This gives you the total 1100. I am telling intuitively, but we have checked with the conditions of the consistency and the data is inconsistent is proved. I am telling you intuitively how it is not correct. That is 600 plus 500 gives you 1100. In 1100 there are 50 members who are possessing both the attributes A and B. Okay. So, even though if the 50 is reduced, you get 1050, that 50 is extra because the population is only 1000. So, 50 is extra, therefore, the data given is not consistent. But this kind of intuitive speaking cannot be done with all the data. We have to check the consistency only through the proper conditions we have studied earlier. Next example is among the adult population of a certain town, 50% are male, 60% are wage earners and 50% are 45 years of age or over. All these are attributes you can represent the attribute male as A and wage earners as attribute B, and the persons who are 45 years of age or over as represented as C. And then the more information is given in the data, that is 10% of the males are not wage earners and 40% of the males are under 45. Make the best possible inference about the limits which percentage of persons, male or female, of 45 years or over are wage earners. Okay. So, two things are given, that is 45 years of age or over are wage earners, and you are asked to represent the limits of the persons. So, B and C are fixed, whereas A is not fixed, A and alpha to be taken together. So, we are requested to find the limits for B and C fixed together with A and alpha. Okay. Let us see how does we go ahead. We will start the solution. Since all representing the percentage, let me take the population as 100 members. Okay. And A represent the male, and therefore number of male are 50%, right? And then B represent wage earners. So, number of wage earners will be 60, and C represent the attribute 45 years of age or over, and they are given to be 50%. And then more information is given in the question. What is that? 10% of the males are not wage earners. Male is represented as A and not wage earners will be represented as beta. Therefore, among the males you should get not wage earners. Therefore, A beta is equal to 10 by 100, which is given to be 10%, and among the males, therefore into 50, which gives you value 5. Similarly, another information is given in the question. What is that? 40% of the males are under 45. Again, males, and they are under 45 means they are not above 45 years of age, where we represented the attribute C as 45 years of age and over. So, under 45 means C is not there, but A is present. C is not there means A gamma we have to do, right? A gamma, and they are represented as 40%. So, 40 by 100 into again with the males, therefore 40 by 100 into 50 gives you 20. Okay. Then AB is equal to A minus A beta. A is 50 and you have A beta is 5, which is equal to 45. Then AC we have A minus A gamma. What is A value? 50 minus A gamma is 20 is equal to 30. We are requested to find the limits for BC. As I already told you, B and C are fixed. So, we are to find the limits for BC. Okay. First, using the conditions AB, using the criterion for consistency, 8 conditions studied in the criterion. Using that, we have AB plus BC plus AC is greater or equal to A plus B plus C minus N. Okay. We have got all the values, so therefore, we need only BC. BC is greater or equal to A is 50 plus 60 and C is 50 minus N is given to be 100 minus this A, B and BC goes to that side as 45 and then minus 30. AB and AC goes that side. So minus 45 minus 30, which is equal to minus 15. So we have determined a limit that BC value should be greater than or equal to minus 15. If you have BC is less than or equal to minus 15, then immediately we can say the data is inconsistent and we cannot proceed further. BC greater than or equal to minus 15 means it can have the values from minus 14 to plus infinity. Okay, and if it has the values from minus 14 to 0, it means the data is again inconsistent. We have got one information that BC is greater than or equal to minus 15. So let us proceed further to see the exact limits of BC. Okay, BC we have using the criterion for condition for consistency, AB plus AC minus BC is less than or equal to A. Therefore, taking that BC to the other side and bringing that A here, this can be reorganized as BC is greater than or equal to AB plus AC minus A. AB is 45 plus 30 minus 50, which is equal to 25. So we have got one limit, that is 25 is less than or equal to BC. The left hand limit is found. Next we shall find out the right hand limit using another criterion for condition for consistency, that is AB plus BC minus AC is less than or equal to B. Okay, we want the limits for BC. So BC is kept as it is less than or equal to B minus AB plus AC. What is the value of B? B is given to be 60. AB we have found out that is 45 and AC we have found out 30. 60 minus 45 plus 30 is 45. Okay, so we have got another limits that is BC is less than or equal to 45. Combining the two limits, we have 25 is less than or equal to BC is less than or equal to 45. So the value of BC lies between 25 and 45. And another thing to be noted is BC is taking the value as positive. Therefore, there is a chance of the data being consistent. Although we have got BC is greater than or equal to minus 15, we have got a little closer result, that is BC is taking the value from 25 to 45. Therefore, it is being positive, and these are the maximum possible limits for the required thing in the question. What is that? We are asked to find out the possible inference about the limits within which the percentage of persons, male or female, of 45 years of age are wage earners. Okay, you got a percentage of wage earners of 45 years of age or over must lie between 25 and 45. This is the conclusion or the inference we arrive at the data given in the question. Now, after studying the consistency of the data, let us go further into the study of attributes by studying the independence of attributes. Two attributes A and B are said to be independent if there exists no kind of relationship between them. That is, if A and B are independent, we would expect the same proportion of A's amongst B's as amongst betas. That is, say that A is independent of B means A should be independent with B as well as with beta. Similarly, the proportion of B's amongst A's is same as amongst its negative part, that is alphas. For example, if blindness and deafness are independent, for a member, the proportion of the blind people among deafs and non-deafs must be same. We have studied with the criterion for consistency of the data. There is also a criterion for independence of the attributes. If A and B are independent, then AB by B is equal to A beta by beta. Okay. 1 minus AB by B is equal, that is taking negative on both sides and subtracting with 1. 1 minus AB by B is equal to 1 minus A beta by beta. 1 minus AB by B is B minus AB, that is written as alpha B divided by B, is equal to beta minus A beta, which is alpha beta by B. Similarly, AB by A is equal to alpha B by alpha, again taking the negative part on both sides. 1 minus AB by A is equal to 1 minus alpha beta by alpha. Okay. Therefore, A minus AB gives you A beta by A, and 1 minus alpha B gives you alpha beta by alpha. In fact, the equation 1 and equation 1.1 are equal to each other, and then vice versa. For example, 1 gives AB by B is equal to A beta by beta. This is what is equation 1, right? What is equation 1? AB by B is equal to A beta by beta. So, AB by B is equal to A beta by beta, which is equal to adding both on the numerators and the denominators separately. This is called proportion addition. We can do it like this: AB plus A beta divided by B plus beta. AB plus A beta gives you the total number A, and B plus beta gives you the total number of members in the population, therefore A by N. Similarly, AB by A is equal to B by N. We have started with AB by B is equal to, we got A by N. Similarly, if you have AB by A, you will have B by N. Then subtracting the proportions, B minus AB is N minus is divided by N minus A. This kind of proportion addition and subtraction is possible according to the law of proportions. B minus AB gives you alpha B by N minus alpha is alpha. It becomes easier to grasp the nature of the above relations if the frequencies are supposed to be grouped into table as follows. Attributes A and B. If a member is possessing the attribute A and B, then it is represented as AB, and if member is possessing the alpha attribute and B attribute, then it is alpha B. When you take the total of class frequency, it is B. Similarly, we can do it on column wise also. AB plus A beta is equal to A. This is what we have arrived at the criterion for independence of attributes. Second criterion of independence may be obtained in terms of the class frequencies of first order, that is AB is equal to A into B divided by N, or you can write AB by N is equal to A by N into class frequency A by N into class frequency B by N, which leads to the important fundamental rule. Now, the fundamental rule of independence says, if the attributes A and B are independent, the proportion of ABs in the population is equal to the product of the proportions of A's and B's in the population. That is bracket AB, frequency, class frequency AB divided by N. That means the proportion of AB in the population is equal to bracket A by N into bracket B by N. Bracket A by N represent the proportion of A in the population, and proportion bracket B by N represents the proportion of B in the population. We may obtain a third criterion of independence for in terms of second order class frequencies as follows, that is AB into alpha beta AB is A into B divided by N. Then this is alpha into beta by N. Okay, and this can be written as A into beta by N into alpha into B by N. Now using AB by N as A by N into B by N and AB into alpha beta can be written as A beta, and then using the same condition, this is alpha B. Okay, so we have got AB into alpha beta is equal to A beta into alpha B. Okay, taking the proportion AB by alpha B is equal to A beta by alpha beta. This is also one of the condition for independence of attributes. In this session, we have dealt with the examples of the consistency of data after studying the criterion for the consistency of the data of attributes. Also, we started studying the independence of attributes along with its three criterions for the independence of attributes. Based on this discussion, the exercise which you can do is given. In a series of houses actually invaded by smallpox, 70% of the inhabitants are attacked and 85% of have been vaccinated. What is the lowest percentage of the vaccinated that must have been attacked? You can represent by attribute A, attacked inhabitants, and then by B as vaccinated. Okay, and you are asked to find out the lowest percentage or the limits for the vaccinated and attacked, right? So vaccinated means B, and you are asked to find out the limits for A, B. Okay, thank you.